Alright, so now we're going to talk about adding and subtracting rational expressions. Now, with this, to add, for example, two just regular fractions, for example, if you have like 1 over, let's call this 18, and you're going to add this to 1 over 12, okay? The thing to do, right, that's very similar to what we're going to do here, is we're going to break these down into factors. Now, yes, it could be broken down into more than these, but I'm going to use these for a purpose. So this would be 18 is 6 times 3, right? And then 12 is 2 and 6, or 6 and 2. So what we do in here to find the least common denominator, I would notice that they have this 2 6's in common, right? They have that in common, but this one does not have a 3. So I'm going to multiply this by 3 over 3. And this one does not have a 2, so I'm going to multiply it by 2 over 2. So therefore, we're going to have 2 plus 3 over my common denominator, which in this case is 12 times 3, which is 36. All right, so the answer would be 5 over 36. So that's the same idea as what we're going to do here, right? The same idea, the same concept, except for now we have functions, right? So to add and subtract rational expressions is what we're going to do. The first thing we're going to do is we're going to factor the denominators. Let's see, this would be negative 3, negative 2. Alright, so factors of 6 add up to 5 that both have to do the same sign, both negative. Alright, so and on this one we have, this is a difference of squares, so we have x plus 2, x minus 2. And now this is the way you need to look at it. Don't worry about the numerator for now. All you're looking at is the denominator. So why do I have to multiply here? What am I missing here? Alright, right here I have an x plus 2 and x minus 2. So what am I missing here that I have over here? I already have the x minus 2, see? I already have those. So therefore, I am missing an x plus 2 on this side. So therefore, I'm going to multiply top and bottom here by x plus 2. And on this side, I'm going to multiply. Alright, now look at it. This is easier once you have done one. Look at it. Look at all those 3 factors. What factor am I missing here? I'm obviously missing the x minus 3, so therefore, I'm going to multiply top and bottom by x minus 3. Alright. So now what I'm going to do after this, I'm going to distribute this, right? So I'm going to write maybe some extra steps that you may or may not need, but essentially this is what you're doing, okay? And I'm going to divide that over my common denominator. Notice that now on the bottom of the fractions, I have the same factors. They might be written in a different order, but they're the same. So that's actually my common factor. Okay, so that's what I got. So what I'm going to do here, please leave the denominator alone. Don't touch it. Don't cancel anything. All right, a lot of people try to do it. Don't cancel any of that. You're going to distribute this 3x and that. Excuse me, you're going to distribute that 3, distribute this 2, and then you're going to add like terms. And that's essentially what you're trying to do. So we have 3x plus 6 plus 2x minus 6. In other words, the 6's cancel. And I end up with a 5x on the denominator. Alright, so I'm going to end up with a, on the numerator. I'm going to end up with a 5x up there, and I have a x plus 2. Let me make sure that they're right. Yep, x plus 2, x minus 2, and then an x plus minus 3, excuse me. Okay, so that's my answer. Please try not to, you could if you wanted to, and multiply the denominator part so you can get one term, or just one function here, but that is just too much work. I'd rather just leave the denominator factor out like that. Alright, so that's it for that. Alright, let's go to the next one. Now the next one we're subtracting, it works the same way. We're going to try to factor, right? So if you know how to factor, then this becomes easy. If you don't know how to factor, this will be hard. Okay? Now I'm going to factor the denominators, and I'm just going to quickly do this right here. because otherwise I'm going to have a lot of stuff written here. Alright, so that's what I got for that one. And if I factor this, actually, this is unfactorable. I just noticed that. So anyways, I guess I'm going to just write that. Factors of 9, that up to 3. I don't have any. Alright, so this is what I got for that. This is a 5, and we have a minus 2x plus 6. Now this is a sum of cubes. Alright, the sum of cubes will be factored like this. We have an x plus 3. Remember, how do I know that's a 3? I know the cube root of 27 is 3. That's all I know. And this is going to be x squared minus 3x plus 9. Alright. This one I think is a little bit easier in terms what is the common denominator. So for the common denominator, look at the denominators, right? What do they have in common? They have those two functions. What am I missing here? What am I missing here that I have here? I'm missing an x plus 3 on this side. So I'm going to multiply this by x plus 3, top and bottom. And I'm going to multiply this side. Right, what am I missing? What do I have here that I don't have here? I'm missing a 2. Alright, so I'm going to multiply top and bottom by 2. So after you have done that, alright, so I'm going to write, we're going to multiply 5 times x, which is 5x, and then 5 times 3, which is 15. Now on this side, I will do something that may seem like I just wrote for no reason, but the number one mistake the students make is that this minus actually subtracts all of this, alright? So essentially what I'm trying to tell you is that you're going to have to distribute that negative 2 to all of this. Notice that that 2 came from here, right, over my common denominator, which now is 2x plus 3 x squared minus 3x plus 9. Alright, so I'm going to distribute that. So we have 5x plus 15. This is negative 4x minus 12. So again, I'm just rewriting the numerator. The denominator is not going to change anymore, so I can add like terms, right? So I'm going to add those two and then add these two. So we're going to have x plus 3, it looks like, over 2x plus 3 x squared minus 3x plus 9. Now, please notice something, alright? Please don't try to cancel anything until you get to your final answer. So this is my final answer. And if this is in factor form, alright, notice that all of this is factor. I can cancel all of this with all of this, but notice that I said all of it. You can't just cancel the x here and here, right, because of this plus. It works out differently. As a matter of fact, Ms. Shelton and I are sort of discussing if this is relevant for you. By that I mean, if you get to this answer without canceling, great. I think we'll just give you full credit for that, okay? Because if you did that much work, then you should get credit for that. Because the canceling part, students tend to mess it up here at the end. They did everything correctly, and then they start canceling stuff they shouldn't cancel. Alright, anyway. So let's go ahead and move on to this part right here. Now, it's the same idea. We're going to factor. And we are going to see what we're missing on each denominator. If you factor this, you get x minus 1, x minus 1. And on here, we're going to get, let's see, that's x plus 1. You're going to get an x plus 2, x minus 1. Okay? Alright, so look, just focus on the denominators, right? So I'm going to cover the numerators so you don't have to pay attention to them. You have this in common. I have that in both of these, alright? Now, what am I missing here that I have here? I'm missing an x minus 1. I already have one, but I'm missing another one. So I'm going to multiply top and bottom by x minus 1. Okay, now look at the denominator again. What am I missing? Excuse me. What am I missing here that I have here in the denominator? I'm missing an x plus 2. So I'm going to multiply top and bottom by x plus 2. And I've been using a different color, but it looks like I didn't do that this time. That's all right. Now go ahead and distribute. Now on this one, again, the actual subtraction part, I just want you to be really careful because One more time, just like I said in the previous problem. This negative right here is going to affect all of this. Okay, so I want you to write it like this. And then you're going to leave that in parentheses essentially, and then you're going to distribute that negative, right? So right now, the denominator is taken care of. I don't need to do anything with that, so I'm just going to worry about the numerator for now. So I can get, I can multiply and add like terms. So this will be x plus 2. Now this right here, x times x is x squared. Then I have x times negative 1 is negative 1x plus x, that cancels, and then you have 1 times negative 1, which is negative 1. Again, please be sure and FOIL. And if you're probably listening to this while doing something else, you probably didn't hear that. Okay, so that's what I got. I'm going to go ahead and distribute that negative. So this would be x plus 2, negative x squared plus 1. Okay, we're going to add like terms. The like terms in this case is just, these are just the only two. So, let me see. Yeah. So that's going to give me x squared, or negative x squared, I should say, plus x minus, plus 3. All over my common denominator. All right, notice that I didn't write my common denominator on the previous step, just because that was just going to be pointless. All right, I just need to add the numerator. If you can, once you get to the final answer, you can try to factor the numerator and try to cancel some stuff. In this case, let's see, there's no factors of 3 that add up to positive 1, I think. Well, with that negative, you're just not going to have anything. I guess you're going to have to take my word for it. All right, finally this last one, all right, this is just a review of what we've done previously. So remember that on this one, your goal is to try to factor. Notice that this is different. We're dividing, we're multiplying. That's all we're doing on this one. We're not adding or subtracting. So dividing and multiplying tends to be easier because all you have to do is factor and cancel, all right? And remember that the only thing that's going to get flipped is this one. We're going to keep this one the same. So we have 4x to the 4th. Let me see, I will do something though just to save me a little bit of time. If you get the common factor out, you get this, right? And if you get that, then that's a difference of squares. So this one kind of keeps getting factored on forever. So x squared minus 1. Alright, and then this right here, let's see if I want to have to factor anything else much more. Okay, no. I'm going to factor this one more time because then I have another difference of squares. So this is x plus 1, x minus 1. Okay, so I did all of that just to factor this top one. Alright, that bottom factor, remember we're talking about factors of 4 that add up to positive 3. 1 positive, 1 negative. Now again, if you struggle with factoring, then you need to come see me, right? Because I'm not necessarily taking a whole lot of time to explain how to factor yet again. Alright, remember on this is going to get flipped, so the 2x is going to end up on the bottom. Alright, remember I changed that to multiplication, that ends up on the bottom, and if I factor this, I'm going to get the common factor, and I get that right there. Alright, now finally on this one right here, we have x, and that's going to give me x plus 4, that's it for that one. On the bottom I have, this is going to be factor by grouping. So I'm going to do this factor by grouping up here so I can just write it all at the same time. So I have a common factor of 2x squared, and that's going to give me x minus 5. This has a common factor of 2, so it's going to give me a factor of x minus 5, which is good. So remember, I'm going to write both of those together here. 2x squared plus 2 x minus 5, but then I just noticed something, right? Notice, what's the common factor between those two? It's actually a 2, so I can actually factor that out. So we have x squared plus 1 x minus 5. Now, if I would have noticed from the beginning, notice that from the very beginning, I could have got that 2 out of it had I noticed that the common factor for all of this is 2. So I could have factored a 2 all the way out, and that would have given me the same answer as what I got here. All right. Now that you have factored all this completely, you're going to cancel as many things as you can. That x squared plus 1 cancels this. Remember, you can always only cancel if one term's on top, one's on the bottom. And it has to be everything or nothing. By that I mean don't cancel this x with this x. It doesn't work like that. You can cancel this x minus 1 with this x minus 1. Alright, x minus 5 gets canceled with this. X plus 4 gets canceled with that. What else we got? Looks like this x gets canceled with that x. And man, looks like a lot of things cancel in this. Let me see. Alright, so I'm going to write what I got left. Actually, this one, this 2 makes this into a 2, and then this 2 cancels this 2 out completely. So all I have left is that 3 and this x plus 1. By the way, and if you're thinking, man, I would have never seen that. Well, you could have written it, since you didn't notice that, you could have written this as 12x plus 1 over 4. And then 12 divided by 4 is 3. That would have got you the same answer. Alright, so even if you do kind of go off a little bit, you still can obtain the correct answer.